These are short snippets from the Quantum Future breakout sessions.
It was great. Christopher, to talk about your discussion, please.
Yeah, there was a big focus on where the hardware was, and even though the topic was software, it's okay. Where's the hardware going to actually be, and which platform is going to be good for what? And there's no really concise answer that can be given there. It's highly nuanced. There are a lot of developments, and there's a lot of still, I think, fundamental R more than D that needs to happen with all of these platforms. Some of the other things that we kind of had to dispel a rumor that, oh, well, you're not going to need classical computers anymore once we have fault tolerance, which is absolutely bollocks. It's not the case. Let's get rid of that in the large room here. You will still need, for example, if you're processing classical data, if you're going to choose hyperparameters to run a fault-tolerant algorithm in one way or another, you still need to do pre-processing. That's going to happen all on a classical computer. You're not going to do also floating point operations pre or post-processing on a quantum computer. That'd be a very expensive way to do that and be silly and slow. There's always going to be, a large classical component. The other thing that's kind of a tandem to this topic is that hybrid algorithms are going to disappear once we have fault tolerance. Well, no, heuristics are still 99% of what we do in most industrial enterprise solutions. So you're going to do heuristics, even using a quantum computer to do a piece of those heuristics, particularly in areas like machine learning that will continue to be important because discrete understanding the exact solution to, say, a PD problem or some other kind of problem like that is, yes, in simulation, a big deal. But many of the problems that we do in compute in industry are not discrete maths problems. That's not what happens. It's a heuristic. So if there's going to be a huge market that's beyond just chemistry simulation or physical system simulation, many body physics, or high energy physics or field theory, and simulation is, we can look at the HPC market. It's 40 billion. It's not going to get much more than that. But if we're going to, really promise the industry that it's going to be trillions and trillions of dollars of value, then it has to be other things that are not discrete simulation math that the quantum computers are going to be doing. We believe that there is a great portion of that. But if that's the case, then the corollary with that is it's heuristics. It's not discrete math. And so there are pieces of heuristics that are still going to exist, which means pre-processing of a latent space, post-processing of results is still going to happen, which means classical computing and the classical algorithms to prepare what you're going to run on the quantum computer is going to be a big piece of fault-tolerant solutions in the end. And so that's a big message that I think gets lost in this. People think that general programmable quantum computer fault tolerant means you do everything on that thing. And that would be like doing everything on a GPU. It's never going to happen. I'll sit here and say that, except in some very isolated and smaller niche markets like simulation that we're all excited about. As physicists, we're excited about. As chemists, we're excited about that. But if you're into, finance predictions and these kind of things, yeah, the Monte Carlo piece will run there. But you're not going to look at a portfolio of stocks on your monitor in superposition. That's not going to happen. So there you go.
No, great discussion you seem to be in there, Christopher. I think that is a really important point, how this architecture is going to come together and how we're going to build that stack or whichever sort of perspective. I think it's going to be really important. And going back to my first introduction, it was like, well, we're not going to just do everything on a web browser. It's going to start becoming bigger back-end computers, mobility devices. This whole architecture is going to change. And when quantum gets thrown into the mix, that's going to change the IT. But more importantly, I think it's going to change the business model and how we operate and that as well. So I think that's really good from what you covered in your section and that here around sort of what we thought was originally just going to be about the big data, but you've covered that architecture in your session. Thank you all very much. Thank you to Ilana, to Kai, to Prem for your fantastic your input on that today. and also to the facilitator who've done a great job. So really appreciate that. So thank you to you all, and we look forward to connecting and keeping in touch with you all. So have a good evening, good morning, wherever and that you are. So thank you all very much.
Thank you.
Yeah, thank you very much.
Bye.
Bye bye.
Bye.